Alright, today we will be working on objective 3.2a, Graphing Quadratic Functions. A quadratic function written in standard form is f of x equals ax squared plus bx plus c, where a, b, and c are numbers. The graph of a quadratic function is called a parabola. A parabola is a U-shaped function that either opens up or down depending on the a value. If a is greater than 0, meaning it's 1, 2, 50, or if it's a third or a fourth or 0.75, as long as it's bigger than 0, the parabola will open upwards, like you see here. If a is less than 0, meaning it's negative 1, negative 2, negative 50, negative a third, negative 0.5, as long as it's negative, your graph's going to open downward, okay? That's what you can see here. Every parabola has a vertex and an axis of symmetry. A vertex is the maximum or minimum value of the quadratic. It's also the point that the direction of the quadratic function changes. So if you look at this graph, for example, it changes direction. It starts going down, 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 down. It gets to the vertex, and then it starts going up, 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 up. This vertex is a minimum value because it's the lowest point of the function, and it's where the direction of the graph changes. If you look at this graph over here, you see you have a vertex that's a maximum because it's the highest point on the graph, and it changes direction. The graph is going up, 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 up. It's increasing. Once it gets to the vertex, it starts going down or decreasing. The axis of symmetry is the line that cuts the graphs in half. It's a vertical line, and it is written as x equals some number. It's always going to be the x value of your vertex. For example, here this is 1, 2, 3, 4, so x would equal 4. If we're looking at the other graph, its axis of symmetry crosses here at negative 1, negative 2. So the axis of symmetry here would be x equals negative 2. It has to be written in that form. It has to be x equals some number. Moving on, we have our first example. We're being asked to graph f of x equals x squared and g of x equals x squared plus 3 on the same axis. If you look at our table, I'm going to choose values for x and plug them in, and then I'm going to use those same x values for g of x, and I'm going to plug them in, and I'm going to graph both sets of values. So my x values I'm going to choose are negative 2, negative 1, 0, 1, 2, and we might do 3. When I plug this in, this becomes negative 2 squared, which is 4, negative 1 squared, which is 1, 0 squared, 0, 1 squared, 1, 2 squared, 4. You know what, we're actually not going to do 3 because 3 squared would be 9, and we're not going to have enough room on our graph. So the points I have for f of x equals x squared, I'm going to go ahead and plot on my graph. The first point I have is negative 2, 4. So I'm going to go on the x-axis, I'm going to look at negative 2. And on the y-axis, I'm going to look at 4, and I'm going to plot the point. So negative 2, positive 4. That's going to be right there. Then I have negative 1, positive 1. 0, 0. 1, 1. And 2, positive 4. That's going to be the graph of f of x equals x squared. We're going to put arrows on both ends because a quadratic function is continuous. Next, we're going to look at g of x equals x squared plus 3. Same deal. I'm going to take my values and plug them in. So my values are going to be 7, 4, 3, 4, and 7. Okay, so I will have room for the 7s. So I'm going to go ahead and plot those points. I have -2, +7. 1, 4, 0, 3, 1, 4, and +2, 7. And there's my new graph. So basically what happened is when we added 3 to x squared, we took the graph of x squared and we moved everything up 1, 2, 3 units. That's all that this plus 3 did, was take this graph and move it upwards 3 units. So here's the rule. Graphing parabolas in the form of f of x equals x squared plus k. If k is positive, it's going to move the graph f of x equals x squared up k units. And if it's negative, it's going to move it down. So if we look at this, we have f of x equals x squared plus 2. Well, I know that x squared is always going to have these points. It's always going to have a point at 0, 0, at -1, +1, at +1, +1, and at 2, -2, 4, +2, 4. That's always going to be f of x equals x squared. But because I have this plus 2, I need to take these points and move them up 2 units. So if I start here at -2, +4, and I move it up 2 units, that's going to put me here. If I look at -1, +1, I move it up 2 units, it's going to put me here. 0, 0, moving up 2, gets me there. 1, 1, move up 2, gets me there. And +2, +4, if I move up 2 spaces, it'll put me right there. So again, we have our new graph. If you look at our second example, we have f of x equals x squared minus 4. So again, we're going to start with our normal graph, which has a point at 0, 0, 1, 1, 2, 4, -1, +1, -2, +4. And because we're being asked to take our f of x equals x squared and subtract 4, we're going to move everything down 4 units. So I'm going to start here at -2, +4, and I'm going to move it down 4 units. That's going to put this point right here on the x-axis. -1, +1 is going to bring it down to -1, -3. 0, 0 is going to become 0, -4. 1, 1 is going to become 1, -3. And 2, 4 is going to become 2, 0. Everything got shifted down 4 units. Okay. Example 4. The graph of f of x equals x squared minus 6 is shown below. Identify the vertex, axis of symmetry, y-intercept, x-intercept, domain, and range. The vertex is the point that changes direction of the graph. And this is going to be at the point 0, comma, negative 6. The axis of symmetry is the line that cuts the graph in half. And it's always the x value of the vertex, so x equals 0. The y-intercept is where the graph crosses the y-axis, and that's, again, at the point 0, negative 6. If it wasn't so obvious that, hey, it crosses the y-intercept here, what you would need to do is take the function f of x equals x squared minus 6 and make that a y. To find the y-intercept, you would plug in 0 for x, so y equals 0 squared minus 6, y equals negative 6. So your y-intercept is 0, negative 6. Okay? That's only if it's not obvious as to where the graph crosses the y-axis. Okay. To find your x-intercepts, if you look, the graph crosses the x-axis in two places, here and here. However, it's not obvious where it crosses. It doesn't cross at a perfect spot. So I can't say, oh, it crosses at 2 and it crosses at negative 2. It doesn't. So what I need to do is take f of x equals x squared minus 6, change this to a y. And because I'm trying to find an x-intercept, I need to replace y with 0, and I need to solve for x. To solve for x, I would add 6 to both sides. Then I would take the square root of both sides, and I would know that x equals positive or negative square root of 6. So in this case, I'm going to have two x-intercepts. I'm going to have the square root of 6, comma 0, and negative square root of 6, comma 0. Those are going to be my x-intercepts. Domain. Domain comes from the widest parts of the graph. The widest parts of the graph are these arrows. They have a coordinate point. The coordinate point for the left arrow is going to be negative infinity, positive infinity, because this arrow is going to the left on the x-axis, which means it's negative, but it's also going up on the y-axis, so the y value has to be positive. The right arrow has a coordinate of infinity, infinity, because it's going to the right on the x-axis, so it's positive. It's also going up, so it's also positive. If you are trying to find domain, you're looking at the x values. So my x values are negative infinity to positive infinity. My range values, it's how tall the graph is, from the lowest point on the graph to the highest point on the graph. The lowest point on the graph is the vertex. The highest point on the graph is the arrows, and I'm looking at the y value of each of those points. So my y value in this case is negative 6 and positive infinities. So from negative 6 to positive infinity. All right. Example 5. We're going to graph f of x equals x squared and g of x equals x minus 2 squared on the same axis. For f of x equals x squared, we should already know the points we're going to pick. We're going to pick negative 2, negative 1, 0, 1, and 2. When I plug those values in, I'm going to get back out 4, 1, 0, 1, 4. If I plot those points, this will be my graph. Vertex is at 0, 0. Y-intercept's at 0, 0. X-intercept's at 0, 0. It's the most basic graph we can have. Now, if I plug those same points in for g of x equals x minus 2 squared, I have negative 2 minus 2. That's negative 4. Negative 4 squared is 16. 1 minus 2 is negative 1. Negative 1 squared is 1. 0 minus 2 squared is negative 2. Negative 2 squared is 4. 1 minus 2, pardon me, I messed up on that. Negative 1 minus 2 squared. Negative 1 minus 2 is negative 3. Negative 3 squared is positive 9. Sorry about that. And then we have 1 minus 2 is negative 1. Negative 1 squared is 1. 2 minus 2 squared. 2 minus 2 is 0. 0 squared is 0. So we're going to plot those points. I'm not going to be able to plot the 16 because it's too big. I'm also not going to be able to plot the 9. But I can plot those points. So I have 0, 4. 1, 1. And 2, 0. Now if I mirror those points, I should have a 1 and a 4 here. So let's look at what happened. I started off with f of x equals x squared, and I ended with g of x equals x minus 2 squared. The minus 2, when it was inside the parentheses, what it did was it shifted my f of x graph over to the right. Every single point moved to the right 2 units. So when you have something inside the parentheses, it's going to move your graph left or right. Now, in this case, let me erase some stuff. In this case, it was negative. So you would think it would move us to the left. But actually what it did was move us to the right. So it's kind of the opposite of what you would normally think. And we come up with this rule. This rule that says if you have f of x equals x squared minus h, if h is positive, then x squared is going to be shifted to the right. So if you see something like x minus 2 like we just saw, this 2 is actually positive. This sign right here, you have to ignore it. You have to take the opposite of what you see. So even though this 2 looks negative, it's actually positive, and it's going to move us to the right. If h is negative, then x squared is shifted to the left. So if you see something like x plus 2 squared, this positive 2 is going to move us to the left 2 units. Okay? So for these examples, g of x equals x minus 4 squared and x plus 3 squared for f of x, what I'm going to do is I'm going to graph the original function, which is f of x equals x squared, just like we have done the entire time. And then what I'm going to do is graph the new function by simply moving the points over 4 units. Okay? This is a minus. This is a negative 4. The 4 is actually positive. We're going to move this thing to the right by taking each value and moving it over 4 points to the right. I'm going to start with the vertex. The vertex, we already know it's at 0, 0. If I move it 4 units to the right, 1, 2, 3, 4, there's my new vertex. To the left, I'm going to have a point 1 unit to the left and 1 unit up. I'm going to have a point 1 unit to the right, 1 unit up. Then I'm going to have a unit that's 2 units to the right, or pardon me, a point that's 2 units to the right and 4 units up. And 2 units 2 units to the right, and 4 units up. And that's my new function. This -4 moved us to the right 4 units. From here to here, here to here, here to here, here to here, and here to here. It moved the graph over. Same thing with this f of x equals x plus 3 squared. Okay? My original function I'm going to move everything, because this is a positive 3, we're moving to the left. We move opposite of what we see. So I'm just going to move everything over. 1, 2, 3 units. 1, 2, 3 units. 1, 2, 3 units. 1, 2, 3. 1, 2, 3. Boom. There we go. Again, everything got moved from the black to the green. From black to green, from black to green, from black to green. Over 3 units to the left. That's all that we're doing, is moving left and right. The graph of f of x equals x plus 2 squared is shown below. Identify the vertex, axis of symmetry, y-intercept, x-intercepts, domain, and range. So here we're going to look at vertex. Again, vertex is where it changes direction. It should be a no-brainer by now. This is at the point -2, 0. My axis of symmetry is the line that cuts my graph in half. It's at the line x equals -2. My y-intercept is here at 0, +4. I know I didn't do a great job connecting the line with the dot, but that's the point. 0, 4. My x-intercept is where the graph crosses the x-axis, and it's here, again, at the vertex. -2, 0. Domain. The domain of every single quadratic function is from -infinity to +infinity. Always, always, always. -infinity to +infinity. The range is the y values from your lowest point to your highest point. My lowest point, the y value is 0. At the highest point, my y value is +infinity because the graph is going up. So my range is from 0 to +infinity. We've identified everything we've been asked to, so we're good.